Today we're going to solve for x the general form of a quadratic equation written in ax squared plus bx plus c form, and we are specifically going to focus on using the completing the square method to do so. So let us go ahead and get started. So our goal is to solve for x. So here we go, writing out the formula first. Ax squared plus bx plus c equals to 0. In completing the square, the first thing you want to do is factor out your a. And you will always factor out a only in the two first terms of your quadratic. So if I rewrote this quadratic with a factored out, my first term will become an x squared. If I factored out a out of the bx term, I would write it as b over ax. I will close parentheses because I'm only factoring it out of the first two terms, and I'm still going to set it equal to 0. You can obviously check. If I multiplied a times x squared, it reverts back to ax squared. A times b over ax. Notice the a and the denominator a here, those would cancel to a 1, leaving us with a bx term, and then the c matches up. So we didn't do anything that changed the original setup of our problem. Okay? Alrighty. Next, what we're going to do is complete the square. Completing the square requires us to find an extra third term within these parentheses to make this a perfect square trinomial. So right now we have the first term, the second term, we're missing a constant inside of there. We can't just add any regular number in there, but if we do, we're going to have to undo it on the outside, okay? The reason we're doing that is because we want to make this into a perfect square trinomial. So let's complete the square. Completing the square requires us to always take the coefficient of our x, which in this case is our b over a, so the b over the a, and we have to divide this fraction by 2. So since I need to divide it by 2, I'm going to place the 2 right here, and then we need to square it. So simplifying that will give us a b squared over a 4a squared. So this is our new constant that we are going to insert within here to make this go from a binomial to a trinomial. So let's rewrite this. So a parentheses ax squared plus b over ax, our new constant here, plus b squared over 4a squared. I'm going to close that off, plus c, and then I need to subtract what I just inserted. But you have to be careful because what I just inserted was within a parentheses, so that means it has to distribute against that as well, okay? So I'm going to write a multiply here to remind you, but that times that is what we need to undo on the outside. So I'm going to come over here, and I'm going to write the word undo to remind you that we need to subtract it out because we want to maintain the original given equation that we started with. So a times b squared over 4a squared will just become negative a b squared over 4a squared. All right, now what we're going to do next is factor this perfect square trinomial because that was the whole point of our completing the square step. By the way, this was the completing the square step. Okay. So let's factor our trinomial. So here on this step, I'm going to write down that we are factoring our perfect square trinomial. So bring down the a. We know that our perfect square trinomial is going to be a binomial with a square on the outside. We know that they're both plus, so we know we're going to add square root that first term. I'm going to square root that term, and it's going to become a b over 2a, b over, and raise it to the power of 2. So if I multiplied x plus b over 2a times x plus b over 2a, I would end up with that perfect square trinomial. I'm going to bring this entire value down, but I want to eventually get these constant terms together. I want to bring them together. So I notice in order to bring them together, though, that I'm going to need to get common denominators, okay? Because this has a denominator of 1, this has a denominator of 4a squared, therefore they need to be common to bring them into one term. So to make them common, I'm going to multiply the numerator, and the denominator. Whoops, I got it backwards. The denominator and the numerator. I'm going to multiply them by 4a squared so that now I would have common denominator. So c times 4a squared is going to be a, how am I going to write that? Let me put the plus here. 4a squared c. So I'm putting them in alphabetical order. And then minus the ab squared. And I'm going to put them over 4a squared and set them equal to 0. All right, so remember our goal is to solve for x. Here's that lonesome x. We're trying to get all by itself on one side. So there's a lot of stuff that we need to move to the other side. So let's go ahead and move this over for starters. So a x plus b over 2a all squared equals, and I'm going to move this entire thing to the other side. So this will become a negative 4a squared c, and then that will become a positive ab squared all over their common denominator. Okay, so the plus for this term became a minus on the other side. The minus for this term becomes a plus on the other side. I notice that I need to get rid of this a. So I notice also that I have an a in every term in my numerator, so I can do this. I'm going to cross out this a. In other words, I'm dividing by a each term. If I divided this term by a, I would be left with, I'm just going to cross it out, negative 4ac, because a squared divided by a is just an a. And if I divided this by a, I'm now going to be left with a b squared. So now I have x plus b over 2a all squared equals to negative 4ac plus b squared all over 4a squared. Now, the next thing I need to get rid of is my squared. To do that, I would need to square root both sides. Square rooting that side will automatically get rid of that squared, leaving us with x plus b over 2a. Square rooting a fraction means we need to square root numerator and the denominator. These terms are adding, so we cannot square root each term. You can only square root terms that are multiplying or dividing by each other. So we're just going to leave them as a combination of two terms. And we're just going to put the square root above them. And then I need to square root the denominator, and that was easy to square root. It was just one term. Square root of 4 is 2. Square root of a squared is a. And I must not forget to place that plus minus when I square root both sides of an equation. Let's scoot this over. So hopefully you're starting to recognize where this entire thing is going. I'm going to move this over. This positive b over 2a will now become a negative b over 2a. And this just comes on down. Since we have common denominators, we can put these two terms together into one term, and they would share their common denominators. So hopefully by now you are starting to notice that this is a formula you are quite familiar with. It's called the quadratic formula, which in essence is the formula that we use in addition to factoring and completing the square and solving by square roots. Quadratic formula is the formula we use to solve for our x-intercepts. So let's rewrite it in the way that we are so accustomed of seeing it. X equals negative b plus minus the square root. We usually put the b squared first. B squared minus 4ac. So we just switch them all over to a. So there you go. There is your short proof on solving general forms of quadratic equations. And what we come to find out is that all you did was end up deriving the quadratic formula.